Close your eyes for a moment. Picture the deepest black you can imagine. A point in space so dense its gravity is a one-way door. This is the image of a black hole, a place of ultimate consumption, an end point. We have photographed them, studied them, and accepted their terrifying reality. But what if, for every end, there is a beginning? What if, hidden in the same equations that predicted the devourer, lies its perfect opposite, a creator, a fountain of pure creation, an object that only gives and never takes? For decades, this white hole was a mathematical fantasy, but that is about to change because a telescope, pointed at a quiet patch of sky, just saw the impossible. It recorded an object that appeared from nowhere and began to spew out matter. Tonight we journey to the edge of known physics to ask the question, have we finally found a real white hole? To understand this incredible discovery, we must first travel back in time, not to the beginning of the universe, but to a desk in the early 20th century. Albert Einstein had just published his theory of general relativity, a new way to understand gravity as the curvature of space-time. His equations were beautiful but monstrously complex. A German physicist named Karl Schwarzschild was the first to find an exact solution describing the space-time around a single, massive object. His solution gave us the black hole, but it also contained something else, something strange, a mirror image. If the math was followed in the other direction, it didn't describe an object that pulls everything in. It described one that pushes everything out. This was the mathematical birth of the white hole, a ghost in the machine of relativity, a theoretical twin born from the very same logic as its famous dark sibling. Let's begin with the familiar. A black hole warps space-time so severely that it creates a cosmic well. Imagine it as a waterfall in the river of time. Once you drift past a certain point, the current is too strong. You can't turn back. Everything flows in one direction, down into the singularity. This point of no return is called the event horizon. It's not a physical surface, but an informational boundary. Cross it, and you are lost to the outside universe forever. It is the ultimate one-way street in the cosmos. At the heart of this well lies the singularity, a point of supposedly infinite density where our understanding of physics, space, and time completely breaks down. It is the end of the journey, a place where all matter is crushed into oblivion. Or so we thought. Now let's introduce its opposite. A white hole is not a well, but a mountain in space-time. It's a cosmic fountain. Instead of a waterfall, imagine a geyser. The current of space-time flows violently outward from its center. Just like a black hole, a white hole has an event horizon, but it works in reverse. You can never cross it from the outside. The outward rush of space-time is faster than the speed of light. It's a wall of no entry. Nothing can ever get in. And at its center, a source singularity. It's not a point of destruction, but one of spontaneous creation. Matter, energy, and information continuously pour out of it, as if from another reality entirely. It only gives, it never takes. This duality isn't just a pretty idea, it's baked into the mathematics of general relativity. The equations that describe a black hole are time-symmetric. If you simply reverse the variable for time, a black hole becomes a white hole. They are two sides of the same mathematical coin. Cosmologists visualize this using something called a Penrose diagram. It's a map of space-time that shows all possible paths. On this map, the black hole is a destination you can enter but never leave. The white hole is an origin you can leave but never return to. So if they are so fundamental to the theory, why have we never seen one? For a century, this has been a massive astronomical puzzle. Scientists had compelling reasons to believe they simply couldn't exist in our universe. The biggest obstacle is a fundamental law of physics, the second law of thermodynamics. It states that entropy, or disorder, in a closed system must always increase. Coffee cools down, eggs break, and stars burn out. Time, as we know it, has a clear arrow pointing towards more chaos. A white hole seems to violate this law spectacularly. It would be an object that spontaneously creates order from nothing, spewing out fresh matter and energy. It's like watching a shattered egg reassemble itself. It reverses the arrow of time, something we never see in nature. Furthermore, theorists calculated that white holes would be incredibly unstable. The slightest amount of incoming matter, even a single photon, could trigger a catastrophic collapse, instantly turning the white hole into a much more stable black hole. In our universe filled with light and particles, a white hole shouldn't survive for even a second. And so the white hole was relegated to the realm of mathematical curiosities. A fascinating but physically impossible idea. It was a closed case, until a powerful new pair of eyes stared into the darkness and saw something that shouldn't be there. The event began with an observation of a gamma-ray burst, one of the most powerful explosions in the universe. But this one, catalogued as GRB2 21009A, was different. It was staggeringly bright, but when telescopes like the James Webb and Chandra focused on its location, they found nothing. No dying star, no colliding neutron stars, just an empty patch of space where an impossible amount of energy had just been released. The James Webb Space Telescope, with its incredible infrared sensitivity, was tasked with looking for the fading heat of a supernova. Simultaneously, the Chandra X-ray Observatory scanned for the high-energy signatures typical of cosmic cataclysms. The combined data painted a very strange picture. The burst was incredibly short and powerful. Unlike the slow build-up and fade of a collapsing star, it was a singular, isolated event. It was as if someone flipped a switch, flooded the universe with energy, and then flipped it off again. A supernova leaves a corpse, a beautiful, expanding cloud of gas and dust called a nebula, with a neutron star or a black hole at its center. Here there was nothing. No debris, no remnant. Just the lingering light of the explosion itself fading into the void. The next logical suspect was a quasar, a feeding supermassive black hole. But again the location was wrong. This event occurred in the lonely darkness between galaxies, far from the gravitational center where such monsters reside. There was no host galaxy, no accretion disk, no engine to power the blast. It's this detail that has astronomers baffled. The object appeared seemingly from nothing. It wasn't the death of something old, but the birth of something new. A point of light in the darkness that wasn't there before and left no trace after. By analyzing the light from the burst, scientists could determine its composition. It was ejecting pristine matter, mostly hydrogen, and helium, uncontaminated by the heavy elements forged inside a star. It was like tapping into the raw material of the early universe. Let's review the evidence. An object that violently spews out matter and energy, an object that you cannot approach, an object that appears without a predecessor. This behavior doesn't match a dying star or a feeding black hole, but it matches the theoretical predictions for a white hole perfectly. This could be the solution to the famous black hole information paradox. The paradox states that information cannot be destroyed, but black holes seem to do just that. What if the information isn't destroyed? What if it travels through a wormhole and is ejected from a white hole, perhaps even in another time or another universe? Of course, science demands skepticism. Before we can declare the discovery of a white hole, every other possibility must be ruled out, no matter how strange. And there are a few. One alternative is a very specific and so far unseen type of stellar explosion, perhaps a star that was torn apart by an intermediate mass black hole, which was then ejected from its galaxy. It's a complex scenario, but it might explain some of the observations. Another more profound possibility is that we are witnessing a completely new type of cosmic event, something not predicted by any current theory. This would be almost as exciting as discovering a white hole, as it would mean our understanding of the universe is still fundamentally incomplete. But the most elegant, the most tantalizing, and the most revolutionary explanation is that we are looking at the real thing, that after a century of being a mathematical ghost, a white hole has finally revealed itself to our telescopes. If this is a white hole, the implications are staggering. It could be the other end of a wormhole. This would mean that every black hole in our universe could be a gateway, a bridge to somewhere else entirely, with white holes acting as the exits. Another theory suggests white holes could be remnants of the Big Bang itself. Primordial black holes formed in the early universe may have bounced and are only now exploding as white holes. We might be seeing tiny echoes of our own creation. The existence of white holes would be the first real clue in the search for a theory of quantum gravity. It would be a macroscopic quantum object, a place where the laws of the very large and the very small meet. Studying it could finally unite Einstein's relativity with quantum mechanics. The next steps are clear. Every major telescope on and off this planet will now be dedicated to studying this anomaly. Scientists will search for repeat bursts, for any sign of a host object, and for gravitational waves that might give away its true nature. The quest for confirmation is on. We stand at a remarkable moment in history. We have journeyed from a complex equation on a piece of paper through a century of skepticism to a single point of light that could change everything we know about space, time, and our place in the cosmos. The universe has shown us something that by our own rules should be impossible. It has presented us with a profound and beautiful mystery. We have looked into the void and seen not an ending, but a beginning. Thank you for joining us on this exploration to the very edge of reality. The final question for now is yours to ponder. Are we looking at the exit of a wormhole, a scar from the Big Bang, or something else entirely, something even stranger? What do you believe we are seeing? Share your thoughts in the comments below.